So let's look at a couple more example problems for finding the volume of rectangular prisms. And I've written the formula down that when you're finding the volume of one of these rectangular prisms, you multiply the length by the width by the height. So essentially, you're finding the product of each of these dimensions of the prism. And often you'll see the formula just written with letters that V for volume, is equal to the length, L, multiplied by the width, W, multiplied by the height, H. And it could be written in different ways. You could see it as the width times the length times the height, or maybe the height is first. It doesn't really matter. These words are essentially interchangeable because if you want, you could just imagine rotating your rectangle in whatever direction you want so that one side is up and the others are on the bottom. So to use this formula, we essentially just need to label each of our side lengths. And again, it doesn't matter which we call which, but maybe we will call this the height, so that can be H. Maybe this could be our length, L, and this could be our width, W. So let's just plug everything into our formula that the volume of this rectangular prism is the length, which is 5 centimeters, multiplied by the width, which is 3 centimeters, multiplied by the height, which is 4 centimeters. Now, just looking at the numbers, 5 times 3 times 4, we can do 5 times 3, that's 15, and 15 times 4, that is 60. And then looking at the units, we are multiplying centimeters 3 times. So we can just write that as centimeters to the third power, or we can say this has 60 cubic centimeters. Remember, with volume, we are going to deal with cubic units, since we're talking about three-dimensional space, or essentially how much three-dimensional space the object takes up. And if we really wanted, we could check this by splitting up this figure into a bunch of unit cubes and then counting them up. So we did that in our first two intro videos for finding the volume of these prisms, but that's a tedious process. When you're just working with these on your own, you can just use the volume formula. And this becomes more relevant the bigger the side lengths get. So if we had maybe 23, 35, and let's say 84 centimeter sides, then you wouldn't want to break this up into a bunch of unit cubes. That would take a very long time and it would be very difficult to draw. So in that case, you would just want to use the formula. But if you want to understand where the formula comes from, that does come from splitting up each of these side lengths and on each of these faces, and then at the end you'll have a bunch of unit cubes which you could then add up. So if you want to do that, like for instance this side, we would split into 3 pieces and then it's 4 high, so we would split that into 4 pieces where each of these, this is not drawn to scale, but each of these has length 1, and we would repeat for the other 2 sides, and again you would notice that you end up with a bunch of unit cubes that you could then just add up. But like I said, that's a bit of a tedious process. So you can always just rely on the formula and understand that the formula comes from just breaking this up into unit cubes. Let's do one more problem. And again, we're finding the volume of the rectangular prism. And I'll write the formula again. So volume is length times width times height. And we just need to label everything. So we can call this the width, this can be our length, and this could be our height. So let's just plug everything in now. We have that our volume V is equal to the length, which is 6 centimeters, multiplied by the width, which is also 6 centimeters, and the height is 1 centimeter. So 6 times 6 times 1. 6 times 6 is 36, and 36 times 1 is still 36. And we have centimeters multiplied 3 times, so that will give us cubic centimeters, or centimeters to the third power. So the volume of this rectangular prism is 36 cubic centimeters.